Hi everyone, welcome back. In this video, we're going to look at the multiplicity of a zero. And by this, a zero, we also know zeros as x-intercepts. Okay, so this is going to be section 3.4 in your textbook, and it's covering R12. So what I'm going to do here is I'm going to take this equation right here and I'm going to graph it using Desmos, which is an online calculator. Now, we are going to look at this statement here. So if P of X has a factor of A minus X n times, so that means how many times or the power on it, for example, we say that X equals A is a zero of multiplicity n. So n would be the exponent that's on there. So for example, here for this one, we're going to look at it and the way we'd say is x equals -1 has a multiplicity of 2. So because 2 is the exponent there. And x minus 2, we're going to say x equals 2 is a zero of multiplicity 1. And so for the factor, this one here, where it's x minus 4 all cubed, the zero is at x equals 4, and it has a multiplicity of 3. So let's go to Desmos and let's have a look at what the graph looks like so we can see how or what it actually means. You'll get a better idea. Okay, so this is my online calculator that I'm using, and it has graphed this polynomial for me. And where we have x plus 1 squared, this is where that zero is. So do you notice how it goes down and then it bounces back up? And if we were to just look at this part of our graph, we would say that it would resemble a quadratic or a function that is y equals x squared, for instance. Okay, so when we look at this zero right here, where x is equal to 2, we want to notice that the power on that factor is 1. And if we just kind of zoom in and just look at that area, we also note that the zero, or that x-intercept, it acts like, or it looks like it just goes straight through, right? So it would be similar to how a linear equation looks like. All right, and now let's look at our multiplicity of 3 here. So our factor was x minus 4 all cubed, and our zero happens to be at 4, and the trend, or the kind of what it looks like at that zero, at that x-intercept, it looks like an x cubed function. All right, so let's go back to our notes and let's have a look at, let's fill in the notes that we have so we can kind of get this down for us so we can remember for later. So if I were to look at a multiplicity of 1, I would say that it would just kind of cross through the x-axis, and it would look similar to, it looks like y equals x at the x-intercept. Here, for a multiplicity of 2, so it's going to look like an x squared. So it's going to go and it's going to hit the x-axis. It's going to hit that zero right at that point, and then it's going to bounce back off. Over here, for multiplicity of 3, this is going to look like an x cubed at the zero, wherever the zero may be. Now I'm using the term zero and x-intercept interchangeably here. Okay, so it's gonna, you know how the x cubed, it's hard to draw. So kind of goes right and then it goes down. So it comes smooth, maybe more like that. Okay. Those are tough ones to draw. Multiplicity of 4, that's going to look like, that's awesome. That's going to look like an x to the power of 4, which it kind of looks like a quadratic if you remember from the beginning of this section, but it looks a little wider. It's wider at the end. It's not a nice kind of tight bounce like the x squared is. It's a little bit wider over here. All right, so the language that we use, the effect of an even multiplicity is a bounce on the x-axis. So we look at these two right here and here. So it's a bounce off the x-axis. It could be either up like this or down the other way, depending on whether it's positive or negative. And the effect of an odd multiplicity is a flattened area, which is often hard to see without the use of technology. So that's why I was having trouble drawing this, right? So it kind of flattens out and then it goes down. And over here, it crosses right through. So let's have a look at these multiplicities. So if I were to graph the x-axis, just kind of real quick here, I would know that my x-intercept is at x equals 1. So if I were to just kind of do a little quick sketch like that, x equals 1, I could say this is x equals 1 right here. And then my multiplicity, it would look like this. It would bounce like a quadratic. So, okay. And you could also connect this to when we were doing the shifts of quadratics. This is 1 over to the right. So it looks exactly like that. Okay, and for this next one here, we have our x-intercept is going to be at x equals -2. So I can just do a little sketch here to show you that this is x equals -2. And it's going to cross kind of like a, it's going to be like the cubic function, okay? I always find those ones hard to draw a nice smooth curve of. Takes a little bit of practice. So practice makes better, I suppose. Okay, so let's continue on with the next page. And we'll see what's going on. So we want to sketch the following graphs. Now this one has a couple of different ones, right? This is going to have x equals 1, and this is going to have x equals -2. This is a degree of 3, so it's a third degree polynomial because I've got my 1 there, so I add the 2 together. So this is a third degree polynomial. The leading coefficient, well, there's an x, there's a 1x here and a 1x here. So when everything gets multiplied out, my leading coefficient is going to be 1. The end behavior, well, this is positive and it's a cubic, so it's going to have the same behavior as that. So it's going to be down in quadrant 3 and up in quadrant 1. So it's going to have this kind of shape to it. But something extra happens in the middle here. So our zeros, we've got -2 as our 0, and we've also got a +1, but this has a multiplicity of 2. All right. And then for our y-intercept, we're going to take this value here, and we're going to take this here, and we're going to multiply it together. So we're going to take our roots, basically, our x-intercepts, which we're going to have 2 -1s, and then we're going to have a 2. And so when we multiply all that out together, our y-intercept is going to end up being 2. And just We covered a sign diagram in an earlier video. So when we look at our sign diagram, we're going to have -2 and a 1 here. That's our roots, and we end up getting a negative, positive, and positive. Okay, and we'll see how that looks. So whenever we've got a positive and a positive next to each other, we definitely have a x-intercept here. So this is represented by the bounce, and then it is going up, and then it goes down when it gets to here. So this is kind of the shape that it's going to follow in our diagram. But we need to get our y-intercept in on that action, and that's our x-intercept and our x-intercept here. So here it bounces off, so we want to draw our bounce. Okay, it goes up there. It goes through the y-intercept, and then somewhere it comes back down and it crosses through that x-intercept. So that would be your sketch here. So this is a bounce off at x = 1. Okay, so if you're daring, you might want to hit pause and try the next one yourself. If not, then you could just follow me along. And let's have a look at this one now. Okay, so I'll go through this one a little bit quicker. Here, the degree is 4, because you take the powers here and here and add them together. The leading coefficient is going to be -1. The end behavior is going to be down in quadrant 3 and quadrant 4, because it's going to end up looking like a quartic, which is the x to the power of 4, but it's upside down because the negative leading coefficient here. My zeros, well, I'm going to have one of them is going to be at 0, and the other 3 are going to be at -2. Okay, so my y-intercept is going to end up being 0, and that's because, well, when this, so I have to make this 0, right? So what value is going to do that? Well, 0 is going to do that. And then my sign diagram intervals here, I've got my -2, 0, and this turns out to be negative, positive, and negative. Okay. So our diagram itself, we need to label that 0. So it's going to cross through 0. It's going to be a straight crossing through it. And at my -2, it's going to follow the pattern of a cubic. So I can go in and just kind of fill that part in first. All right, and then I'm just going to continue that on there and then connect these two different pieces so that it looks nice and smooth. Okay, and I'm not really sure how high this goes. I don't have enough information. I mean, I don't need to figure out how high this actually goes up here for that relative maximum. Okay, the next one says zeros of a polynomial here, for example 3, are -2, 3, and 5. Write an equation to represent this. Well, this -2 means that I've got something that goes x equals -2. This here means x equals 3. And this here means that x is equal to 5. So if I want to write a polynomial, then all I need to do is write x plus 2 in brackets. So we're going backwards, right? And we're writing out what the factors are. And that's what you end up with. Okay, so here in this last one, the zeros of a polynomial function are 0 and -4 with a multiplicity of 2. Write an equation to represent this function. So for this, we're going to have x equals 0. And for this, we're going to have x equals -4. So for that part, that we can write x, that's for the 0. And then this is for here. Oh, sorry, x plus 4. Okay, and this has a multiplicity of 2. So that means that we've got a squared there. Okay, so have fun with the homework and hope to see you soon.